Welcome friends, welcome you all in my channel Chemistry the Mystery of Molecules. I am Tanmay. So today we will discuss a question which was appeared in GATE 2011 exam, and the question is, upon reaction with this sulfoxide with acetic anhydride and sodium acetate and heat, a product is produced X, and the question actually is what is the major product. 4 options are given, so you have to find out which one is the product. So before going to details, I suggest you please pause the video and try to attempt by yourself, and after that I will explain. And initially I will explain everything step by step, and at the end I will explain how to solve such question within 1 minute. So I suggest you to pause and I will explain. I guess you have paused and attempted, so let's start the explanation. First of all, if you see this molecule, so what is expected, what type of property this molecule is expected to have? This is a sulfur double bond, and we know such type of sulfoxide have a canonical form. Canonical form means this is sulfur and this is oxygen with this O is minus and S plus. So this indicates that like carbonyl, you can consider like carbonyl that these alpha hydrogens are relatively acidic, and when we add slight excess of acid which activates this, and ultimately what produces? It produces OH, and one can first it produces this acid based product with formal charge on oxygen. Then this negative charge comes on oxygen, which results formation of carbocation here, and that is the reason why after addition of slight amount of acid, means acid or Lewis acid, the acidity of this hydrogen increases. So this is the basic fundamental thing which will be utilized in this example. So this protons are relatively more acidic, and right now what reagent we have given? That is acidic anhydride. What is the structure of this reagent? This is. So you can see this acidic anhydride is nothing but it's an ester, and with here 2 carbonyl group is bridged by 1 oxygen. And we know carbonyl is electron deficient, as I told just some time before. And another thing, when any attack happens here, then it push-pull, this comes and it produces acetate, means NeCO minus, and this is a stable anion due to resonance, and that's why it's a good leaving group also. So this thing happens here. So here acetic anhydride. So this acetic anhydride, this oxygen attacks here, goes, and this, so it means after the reaction acetate anion leaves. Okay, and what it produce here? SOOCH3. And right now, just I told about this. Previously it was a conjugation, but right now this sulfur is highly electron deficient. And this is highly electron deficient means the acidity at this position increases. Okay, that's why it could easily be extracted by base like sodium acetate. Previously you can see this, another thing, during that reaction some acetate also generated, and this acetate abstract the proton. Okay. So what it produces? It produces positive and OAC, and here minus. Now you can remember this is a ylide. This is a ylide moiety having plus and minus charge close together. Okay. Previously when I have discussed during the stability of carbonyl, I have explained sulfur ylide, phosphorus ylide, even phosphorus ylide, which is extremely used in Wittig reagent, also stabilizes the VTP agent also stabilizes by the conjugation with the phosphorus using the vacant d orbital of the phosphorus atom itself. So this is stable, and stable, how we can draw the canonical structure, that is sulfur OAC, and here the no charge should be here. So in this way this oxygen is forming a multiple bond with sulfur and is stabilized. Now another point, that the most important step of this reaction. So this sulfur with OAC. Okay, and here let's consider as a double bond. So it is with the conjugation. So this OAC minus leaves, because previously I have explained that OAC is a good leaving group, so it leaves. So we can write in such a way that this. So what happens? This sulfur is, and see, it was a neutral molecule. 1 unit of negative charge eliminated, so don't mistake. So it will be positive. So such type of reaction with sulfur you can observe with sworn oxidation, where you also be careful about the positive charge on oxygen, sulfur. So be careful here, the chance of mistake is more. So what happens? This double bond, and right now you can consider this double bond as a carbonyl, means you can consider thiocarbonyl, like this. It's a carbonyl attached with some, and this became. So ultimately, if we draw a canonical structure, then it will go here and this carbon will get positive charge. Means if we draw this canonical structure of this moiety also, then you can see that this can come here and produce this. Sulfur is neutral, cationic charge in oxygen. So what does it mean? That this carbon center is electrophilic, means electron deficient. So any electron rich molecule can attack here, and previously in medium there is enough amount of acetate which is electron rich, and acetate, due to this resonance it is a good leaving group as well as good nucleophile, because this negative charge is stable, delocalized. So acetate, and another thing, its electron deficiency is higher, that's why acetate is capable to attack this O minus. This O minus attacks, and actually we write in this way, but actual writing should be from this oxygen. Why? Because it is minus, it is in conjugation with this, so this portion should attack, but doesn't matter. So this is, and what will produce? Sulfur with OAC. Okay, so this is the product. That, so here attacks and this bond opens up, so ultimately sulfur is neutralized this, and right now this molecule is not reactive, it will not undergo any reaction. Why? Previously if you compare, this is activated due to the resonance, O minus S plus. So electron deficiency was there, then it attacks, and right now there is no center left for attack. Okay, so this will not undergo any reaction, and so this is the product. Now let's see which option indicating this. OAC, this is. So this is the answer. Okay. So in case of this, it is not expected because it's an elimination, and elimination, actually such type of reaction you will observe in case of pyrolysis of xanthate. Actually acetate, pyrolysis of acetate, xanthate, those type of cases you will. Okay, so here no pyrolysis of xanthate or acetate happening, so it will not be the product. And this is not possible because if it need to produce then actually the sulfur ylides formed that need to be attacked. Okay, but that need to be attacked. But before attacking these eliminates, and which produces a cationic sulfur species. What do I mean? This. So if it forms with a cationic species, the availability means this center is electrophilic, not nucleophilic. So this center cannot act as a nucleophile because of the presence of this sulfur. Okay, you may consider the thing in that way that when OAC was attached here, means when OAC was attached here and it left, this is minus, this is plus, actually this negative charge is went out in this fashion. So that's why right now it is not electron rich that it can attack the acetate, means acetic anhydride like CH3CO, CH3OCO, that it can attack this carbon and try to leave this acetate. So acetylation not possible. So this is the trick. If you don't understand this, the role of leaving of this, then you will end up with mistake using this one. Okay. So, and it will not, this product will not form because here no such type of reaction is happening. And most of all, there is a name of this reaction. This reaction is named as Pummerer Rearrangement. Okay, please keep the name in your mind. The whole reaction is called Pummerer Rearrangement. Okay, so right now I am going to explain you the tricks to solve such question. The tricks is when you watch this, and I believe you don't know about this, then you know the resonance of this sulfoxide means sulfur plus oxygen minus. So it is expected that since if sulfur is oxygen is minus, so it will attack acetic anhydride and it will produce OAC. So when OAC form, there will be a chance of formation of this negative charge here in presence of base sodium acetate. So such type of thing is there. And another thing, in presence of this it will leave. Then actually you have to think about the mechanism in your mind first. Then only you can do. And initially when you see the options, these will not produce. These will not produce. So the confusion is whether this or this. And now the question, is it possible to stabilize negative charge near to sulfur? What do I say? So, while you are thinking that negative charge near to sulfur, it is very difficult to stabilize negative charge near to sulfur. Compared to that, positive charge could be. Okay, because of the conjugation. You can think like that. So, it is difficult to stabilize negative charge here. So, this product will be produced if here negative charge. This product will be produced if here positive charge. Okay, this. So, in this way, you can solve this question within 1 minute, I believe. And another thing, since I told stabilization of negative charge is difficult here, let me give you one real example. I have told previously also, this is known as thioacetal protection. Okay, this is R1, this is H. In case of aldehyde, this is possible. And in presence of butyl lithium, okay, this butyl minus is capable to abstract this proton and this anion is produced, R1 minus. And this is stabilized by the conjugation of the vacant d orbital of sulfur, this anion. In these are two sulfur. So it is not very easy to stabilize negative charge adjacent to sulfur. So from that point, this will be the product. So this is the end of my video. So if you like my teaching, please give me a like and Secondly, please share this video among your friends such that my effort could be beneficial for many people. And please subscribe my channel Chemistry the Mystery of Molecule and press the bell icon to get the notification of every single video I upload. So, see you in my next video.